So the first thing you do is you install this on your computer. Do each of you have a Mac? Are you able to do that?
Yeah, I
Yeah.
downloaded it already.
Perfect. Okay, and so you run this, and it will bring up, a basic front page, which is a documents database, right? Which is a listing of all the studies that you have in your Horos database. Normally, when I import something to Horos, it gives you two options. So if we go out and say we're going to import something that we have set here, I gave you, what was it? It was A01 underscore something, right? Yeah, 2 frames. So if I wanted to import the images that are in this folder, right? Horos is pretty good at ignoring everything other than the DICOMs. And so if there's even other junk in there, normally it'll just ignore it and just import the DICOMs. And it'll read each DICOM header and try and place that image in a reasonable structure inside Horos. And so these are all folders, and then we get to the DICOM files, right? Different manufacturers store their images with different DICOM structures. So sometimes each imaging plane has its own DICOM file. Sometimes a whole volume will have one DICOM file. So don't let that trip you up. This looks like it's a 0.5 meg, so this is one image probably, right? And they're enumerated in whatever the vendor decided to enumerate. It could be series 1, and this could be image number or whatever. The great thing about Horos is it will read all these files and read stuff in the header and sort them out for you, right? So essentially what I do is I just go to a higher level that includes all of that stuff, and you just say open, and then Horos will ask you this question: should I copy the links or should I copy the files? If you copy the files, it will create an additional copy of all those files on your computer in a place called Horos database, right? And so it'll put new files there that are replicants of the old files. So if you want to optimize disk space, I usually just say copy links, right? And so when you copy the links, it will read in the files, right? And it'll make a new entry in this thing. And where will it? It should have a little orange plus sign since I just read it in. Okay, there it is, right? So that little orange plus sign says that's the study you just read in, if you have many hundreds of studies like I do here. So then you open that up, and so what it just did was it read in the 2 phases that I gave to you guys out of the about 15 phases here, right? So the first thing to do in Horos is, the best thing about Horos is you can just quickly look at the data, right? So what these percentages mean here, and forget the first digit, but the 00, 08, 15 is 0% through the R to R cycle, 8%, 15%, 22%. So we're stepping through the R to R window of the QRS. So these are just equivalent to time delays in the images. If we read in, let's see what I got here. There's 256 images in each one of these. You can think of this as a folder, right? So this is the patient name, and then these are the folders under the patient name. That means there's 256 slices represented in this. And this is where modern computing is wonderful, because I can, without much hesitation, say, okay, I'll download, let's say, all of this stuff from, well, let's go from 0% to 295. So that's 1 R to R. I have extra images on the end. Then you say 4D viewer, okay? And it's going to take this whole set of these volumes, these are 256 slices each, and load them into memory inside Horos. And so 4D viewer, and now I can look at my first set of slices, and what I'm doing is I'm taking 2 fingers and I'm, going up and down on my mouse pad, or you can take the arrow and you can run up and down here, right, to go through the slices. You can also use the left, right arrow keys to go one slice at a time, okay, in space. So, you know, you can quickly just look at the picture, right, and see what we've got. For this patient, for example, we have, you know, the left ventricle, right ventricle. It looks like most of the contrast is in the left side of the heart right now, and in the aorta, descending aorta. This is the patient's chest cavity with ribs, right, and their sternum. And you can see there's a lot of space between air and their sternum. So this is actually a fairly large person just by looking at the CT. So we'll be challenged probably with signal to noise because the x-rays have to get through this person. So again, going with my two-finger method, I can raster up and down and make sure all of the slices look okay. And if you notice, so that does look okay. See all the bright stuff coming in the aorta? That's calcium on the wall of the aorta. That's never a good sign, but this person, you know, we don't have their age, but they're probably old enough, obviously, to have a lot of calcium on the wall of their aorta. And so these images that we've loaded here are in the axial coordinates. That means they're, when you look down the bore of the scanner, these are like perpendicular. So we can take a look at the 3D view and get an idea of what that means. So let's look at this. Oh, first, remember I downloaded, I don't know, 14 timeframes or something? If I do the up and down arrow on my computer instead of the left, right, first make it active, I go through time at that slice, right? So now I'm staying in the same slice in the patient, and I'm looking at all those different time frames. And if I just hold the button down, I can watch a movie. So that's my down arrow. I'm going forward in time. And you can see that this is playing forward in time. If you want to set your view to a specific time frame, you just click this arrow back and forth. You can play that movie I was just doing that way, and then stop it. This is the first, second, third, fourth, fifth, sixth, seventh time frame is here, right? So we'll look at the seventh time frame there. I can then go to look at different views of that volume. This is called 3D MPR off to the side here. And it will bring up 3 panels. And I've set this view. How do you set this view? I think it might be one of these. I'm looking to see if it'll tell me. Maybe, as you can see, there's a ton of stuff on here. Image tiling. Yeah, 1 row, 1 column. Well, I don't know how it puts them up in this view. You'll have to hunt around for that. But if it comes up in a different set, I would go back to this where you have, this is the sagittal view. Chest or anterior wall is here, posterior down here, that's their back. Left, right, anterior, posterior, right? And then this is inferior, superior, and left and right. Okay. Now you can move through the volume, you know, with this cursor to take a look at things. And so I have the same axial slice, and the orange line tells me how I'm cutting the volume to look at this. I'm sorry, this slice here, this sagittal slice. So there's this little orange thing up there, tells you that's the orange slice. And then the horizontal line is the coronal, which shows me this view. So that's just like slicing the top off and looking at it that way. Now, the other great thing for cardiac imaging is I can adjust the angle of those views. So if I want to put, and this is what I always do when I'm looking at the function of a heart, I'll take this. You can actually put this down towards the apex and then, you know, center up the angle so that this line is going between the, you know, this is the mitral valve plane here, you know, sort of bisects the corners here. This is the short axis view, it's called. It's going through the apex of the heart. And then here it looks like we're tilted down towards here. So I'll just rotate that up just a little. And that gives me the classic views of the left ventricle when I now go here, use two fingers once again in order to page through the views inside this window. It moves the cursors over here. And so this view is called the mid level. So it's halfway through the heart. This is a short axis view. This is called a four-chamber view because you have the left ventricle, the right ventricle, basically the bit of the right atrium and the left atrium all in one view. And this is called a two-chamber view because you have the left ventricle and the left atrium in that view. These are classic views. The other classic view for looking at the heart would be to take this and rotate it approximately 45 degrees to go to the place that I haven't seen yet. And the rotation, I usually adjust the rotation amount such that I can see the aorta and I can maybe move the center a bit. Well, this is a weird geometry actually. So here, move this down. So there's the aorta. So this is the left ventricular outflow tract here. And we can look at the structure of the outflow tract. And so we're cutting through the patient along this plane, and then we cut through the heart to see the left ventricle and the aortic outflow tract. And this is called a parasternal view. And this is sometimes called a horizontal view because it's kind of parallel to the floor. Right? So those are the classic views that you can get. Inside each one of these windows, we can zoom up. And so if you go to the 2D viewer, pull down and say scale, you can tell it to go actual size and it will zoom this thing up in your field of view so that you get a better look. I believe if I double click on this, it brings up just that view. And I can, again, with my two fingers, page up and down and look at the different short axis slices, right? So this is the left ventricular muscle. And what you guys are interested in is isolating these things, which are the coronary arteries, right? And that's running down the central groove between the RV and the LV is this coronary artery. And you can, as we play through different time frames, unfortunately in this mode, when I'm in the 3D mode, I can't use the up and down arrow. It'll just do a magnification. I have to click through time frames this way. And we can see the change in image quality as we go through time frames, right? If I go to a later time frame, the heart is moved actually towards the apex. And the chamber gets a lot smaller. The coronaries change their look because they're moving. And so this is end systole when the chamber is at its smallest, right? We've ejected most of the blood. And we come out here and we can look at the coronaries. And this person's right coronary artery, as we go around here, as you can see, has a big chunk of calcium in it right there. And yeah, so as we page up and down, we can see that artery pretty clearly. If you wanted to try and get all of this artery in one view, you can do a trick, which is up here. This is maximum intensity projection, but I'm only projecting over one slice, which is 0.65 millimeters. I can actually open that up to project over more slices. Right, so here it's 15 millimeters, 16 millimeters. So it's a lot of slices. And so now I'm projecting through a slab of the patient and I'm looking at the maximum signal inside that slab. And I can see that piece of calcium here and the rest of the right coronary artery. And I can also see that the surface of the coronary artery is pretty rough. So it's not a nice smooth artery. So that would indicate that there's, disease in that artery. So that's moving, and now I'm moving up and down by using two fingers to move that whole slab up and down. If I go back by double clicking to my previous view, that double click pulled me back to this view. This shows you the width of that slab that we're projecting through. And so if this is blue in the corner here, this is the slab that we're projecting through here. And if we look at where the right coronary artery is, it's over here. I can probably rotate that slab maybe to get more of it in there, right, like that. So now I've centered up on the right coronary artery, and I'm looking at that slab. If you guys have questions, just jump in, okay? And I'll stop and try and explain it. Okay, so that's viewing things orthogonally. If you have a view that you think has captured something that you want to save in that view, it might be hard to recreate at some other time. You can actually save this whole view as another DICOM file. And so what I do is every time I click in a window, you see that window becomes active. So now the purple window is active. I click here, the blue window is active. That's one single click. If I say Command E inside here, I can then write out this image and this image and this image together. And so what I'll do is an NPR, let's say RCA slab 1. Best rendering, 4th dimension. So that means I'm going to get every time frame as well as this time frame. You could do the current image only, but let's do the 4th dimension just for the heck of it. Size, let's just include all views. If I do current image only, I think, oh, if I take off include all views, I can also capture the full 16-bit data. Now, so if you want, the larger dynamic range with 16-bit data, then don't include all views. So let's include all views still. 4th dimension, slab 1, say okay. And now I think it says it's creating a new series, right? And it's producing those maximum intensity projections at each time point. And we can read that back in if you want to look at it at a later time. Okay? And you can also save those new DICOMs out to disk. And I can show you how to do that really quickly. So I guess it's taking a bit of time to compute this because of the maximum intensity projection. Usually it just does this in about 2 seconds. So, okay, so that's that. Anything else on these? We'll just click out. If I go back now and say up to here to window and say, show me the document database again, and I go back out there, I now have this new folder which has 14 images in it, and it's called RCA slab. And I look at it, and here's what the pictures look like. So they look like those pictures that we saved, right? If I double click on RCA slab, yeah, so it brings it up here. And I'm using 2 fingers just to page through those pictures, and I get all of the time frames of that slab, right? So that could be useful. The other thing that is useful sometimes to look at is the full 3D volume, and you use volume rendering for that. And then I'll read those in. Excuse me, I had to sneeze. Okay, so here you can see the whole volume that's included in our data. These buttons allow you different controls to look at this volume. And so the first one we're going to look at is this button. So a single click on it. And now when I move my mouse, if I press down the left button and drag the mouse, it'll change the center window of the display. So if I push down and go down, everything above a certain level turns white. If I go up, everything below a certain level goes dark. And so here I can set what level I'm going to look at. And then when I go left and right, it changes the window width. So there's a very wide width, very narrow width. So if I go down once again with that width, I can start to create. So now I'm moving at an angle. So I'm changing the width and the brightness at the same time. All right, this takes a little getting used to, but you'll get used to it. And so now you've set. Now let's click from the center and window control to this box, this cube, do a single click on that. And now when I press the left button and pull around, I can rotate the angle, the view angle. And so if you want to look in at just the heart, you can then take these scissors and essentially left button down and then just drag the mouse around like this. And now everything inside this sort of cone or cylinder or irregular cylinder, if I hit enter or return, it'll keep everything inside. So I'll hit return. And if I hit delete, it would delete everything inside. So you can do the complement as well. And so now I've gotten rid of the ribs and the spine, a lot of it. I can now rotate again like this, and I have a more clear view of the heart. Notice the things that you're interested in are these little wispy things here. Those are the coronary arteries. So let's go to magnifying glass, click on it once, zoom up, okay, and then go back to my cube and take a look and see if we can see that coronary artery. That's the right coronary artery coming off here. So our center and window is not adjusted well to see that whole artery. So why don't we go back and we'll see if we can include more of it. Okay, so I've included more. Now, get a better picture of what is included from that artery here. All right, so you can see also the calcium that was there. And why don't we get rid of the descending aorta just for grins. So I'm going to go back to my scissors, come here. Now everything inside this shape, I'm going to hit delete and take it out so that it doesn't obscure my view of the coronary artery. Let's go back to the rotation. So there's my coronary artery again. Right. I probably want to get rid of all this stuff too. But now one of the interesting things is now that you've got this, you can also watch a movie, see how it moves over time. And you can see there are two main times at which this artery looks like it's almost stationary. One is there at end systole, and one is there at end diastole. And the other positions, it seems like the artery is in motion and the images get kind of blurry, right, because of the motion artifact. So it kind of, this is a good way to identify sometimes what the best view is for the whole artery. So if I hit stop here and I go back a couple, that looks like a pretty good view, right? That time frame, because I've got the calcium here. I've got sort of a rough edge there, right? So this gives you a quick overview of the image quality. Go down here, and you can see this artery coming off here is the LAD, right? And it too looks like it has maybe a piece of calcium bulging out of it. That looks like calcium there, right? Okay, so that's the 3D rendering. What else do we need to know about 3D rendering? Oh, if you want to save a movie, you can do this. You can say movie export and a temporal series. And then CW1, I'm just going to say test movie one. And then you hit this down arrow and you have to do this and then hit it up in order to get this frames per second here. Sometimes it's set to 60 for some reason, and then your movie's useless. If you have 10 frames, I think we have about 14 frames per heartbeat. So let's set it to 14 frames a second. And you hit save, and it will capture this screen and make it into a .mov file for you. And so that's one way when you want to show somebody something and you don't want to send them gigabytes of data, you can just send them this movie, right? And then inside QuickTime Player, you hit Option Command L, and then when you play it, it will loop. And so you can take a look at your data looping, right, like that. And now you can see the coherence of the right coronary arteries over here, left coronary arteries there. Okay. And so let's get out of QuickTime Player. We will, I think, I've done anything else there. Now, interestingly, what has happened is when we did that segmentation in the 3D space, it seems to have mapped it back here to the 2D space, right? Which is kind of cool, right? Let's see if it's mapped it back to time frames. So if I hit play, yes, it has, right? So now, I'm not sure, but I might be able to save all of this data with this segmentation intact. You guys should try that. I'm not sure if that works, to tell you the truth. But it would be interesting because then you'd be able to use the 3D space segmentation editor, which is powerful, right? Because it seems to have edited across all time frames, for one thing. And you can see features in 3D that are very difficult to edit in 2D, right? But one way of isolating features in 2D, and you guys will want to sort of isolate probably this feature, right? This is the coronary artery and the tissue around it, right? Is just to put a, maybe a center line through it and then a radius around it that goes through space. The previous team may have already done this for you in MATLAB. In order to do that, you can do segmentation or what's called a 3D curved MPR. I do not know how to do this. I've never used this, but it may be useful for you guys because you want to put points along this coronary artery in 3 space and have that plane, that curved, multi-planar reformat come up as a picture. So I would look, just Google Horos or Osirix, which is the commercial version of this program, 3D curved MPR, and you'd probably want to learn how to do that as well. Okay, let me see. The other thing I was gonna show you is if you want to save something that you've created, right? You can select it and then go to export. Hit export and then the CWA01, and then you can even put it in a new folder and say my export, right here, and then hit choose. And it will write these images, these 14 images, or however many are in that folder. And you can do it for multiple folders, not just one folder. And you can select the whole study and export it, right? Or you can select folders and export them. Then when we go out, okay, it made a new folder, my export. And in there, it made the structure with new DICOMs, and there should be 14 of them, and there is, right? Each DICOM is quite big. It's 10 megabytes because it has all that stuff on it, right? I think you can then, let's see if this is true. If I go to ImageJ, which is another free program, and you want to analyze one of these DICOMs, I believe we can just copy it into, yeah, you just copy it into ImageJ and then use that program to do subsequent analysis, right? So, you know, you have the pixel values here. Again, looks like it's 8-bit color data, right, is what has been saved. Is the, you know, you have 3 numbers up here. 196, 196, 196, which is the gray value of this. And then what does it encode the background as is 10. I don't see any error, so okay. All right, so that's another way of like quickly doing some analysis with that program, is to take the DICOMs that you saved. These can be read back in by Horos, of course, and then this movie you can just send in an email to your friends or whatever and look at what you've saved. Okay.